Good morning, dear students. My name is Ferhan Mazher, and today is 10th of November 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O-Level Physics. Today, we have set our hearts to solve October-November 2007 paper 1. It's an MCQ paper, and we will solve this paper. So let's start. And so here we go. This is the question. Okay, so October, November 2007, paper 1. It's a multiple choice question. In an experiment, a ball is rolled down a curved track that is about half a meter long. Which measuring device should be used to measure the length accurately? Because this is curved path, so you should use something which is flexible. So the tape measure will be the best option, I think. So my opinion is the tape measure can be the best thing to measure the length of this track, because this track is curved. So we should use something which is flexible. So I think question number 1C is the choice. Let's check the answer. Question number 1, C is the choice. Forces of 30 Newton and 50 Newton act on the same body, but in different directions. Which value could not be the resultant force on the body? So there are two forces they are talking about. So let's check. Okay, so there are two forces acting, 50 Newton and 30 Newton. They can have the maximum resultant when they will be parallel to each other and they will be acting in the same direction. The resultant will be the sum of the two forces. That will be 50 and 30, and that will be the 80 Newton. And then, the other thing can be that the other extreme case can be that the two forces are acting in the opposite direction. In that case, the resultant will be the difference of the two forces, and that will be 20 Newton. So the maximum resultant can be 80 Newton and the minimum resultant can be 20 Newton. So your resultant will be from 20 Newton to 80 Newton. So any answer which is out of this range, that is not possible. So let's go, let's check. Okay. So from 20 to 80 Newton, anything out of that range will be, the question was which could not be the resultant force. So 10 Newton cannot be the answer. So question number 2A choice. So let's check. Question number 2A is the choice. A speed time graph for a falling skydiver is shown below. The skydiver alters his fall first by spreading his arms and legs and then by using a parachute. Which part of the graph shows the diver falling with terminal velocity? So when you will falling with the terminal velocity, your speed will become constant. So at the terminal velocity, the resultant force is 0 because the downward and the upward force, they are equal to each other. So the resultant force will be 0. So the speed will become constant. So at the point D, I can see that the speed time graph has become flat, which means that the time is passing by, but the value of the speed is not changing. So I think D is the right choice. Question number 3, D is the right choice. So our answer is right. Okay. When a body moves across a rough surface, a frictional force is produced. Which statement about this force is always true? It acts in the direction of the motion. No. It is equal in value to the force producing the motion. That is not necessary. It makes the body recoil in the opposite direction after stopping it. It opposes the motion across the surface. Yes, that's the right answer. It always opposes the motion across the surface. So I think D is the best option. Question number 4, let's check the answer. Yeah, D is the right answer. A car moves in a circle at a constant speed. What is the direction of the resultant force acting on the car? So whenever you're moving in a circular track, the resultant force is always towards the center of the circle. So here we have the center of the circle. So in this circle, the car is turning. So the resultant force at this moment will be towards the center of the circle. So B is the right choice. B is the right choice. A body of mass 10 kg falling freely in the gravitational field close to the moon's surface has an acceleration of 1.6 meter per second square. What is the gravitational field strength on the moon? You see, this acceleration due to gravity is 1.6 meter per second square. Same will be the gravitational field strength, but its units will be Newton per kg. Small g on the moon will be 1.6 Newton per kg. So B is the right choice. Our answer is right. The diagram shows a boy of weight 500 Newton sitting on a seesaw. He sits on 2 meters from the pivot. What is the force F needed to balance the seesaw? If this thing is balanced, you see this boy's weight is producing producing clockwise moment about this pivot. This force will be producing anti-clockwise moment about this pivot. So they both will be equal to each other when it's in balance. So you can see that this force is acting downward and its moment arm, its distance from the pivot is 4 meters. The weight of the boy is acting here and its distance from the pivot is 2 meters, so its moment arm is 2 meters. According to the law, we know that when something is in balance, the anti-clockwise moment and the clockwise moment, they are equal to each other. So let me show you my work. Okay, so here you can see that here 500 Newton is acting and the distance of this force from the pivot is 2 meters. This is trying to produce clockwise moment. The force here, we want to calculate this. Its moment arm is 4 meters. Its distance from the pivot is 4 meters. This will be trying to produce anti-clockwise turning effect or anti-clockwise moment. So according to the law of the momentum, principle of momentum, anti-clockwise moment is equal to the clockwise moment when the seesaw is in balance. So the clockwise, anti-clockwise moment will be force multiply and the moment arm, that's 4 meters, equals to the clockwise moment will be the weight of the boy, that's 500 Newton into its moment arm, that is 2 Newton, 2 meters, sorry. So it will be F into 4 equals to 500 into 2. So the F will be equal to this 4 will go on the other side, it will divide. So you will have 2 ones are, 2 twos are. So 500 divided by 2, and that will be 250 Newton. So it will be 250 Newton. A is the right answer. So let's check. A is the right answer. A spring balance is calibrated to give reading in newtons. The graph shows how the length of the spring varies with the load. So here on the y-axis, the length of the spring is shown. On the x-axis, the load is shown. So you know when there is no load, What's the length? That is 2. The length when the load is 0, the length is 2. So that is called L naught. He says a load causes the spring of the balance to extend by 3 centimeter. So the extension is 3 centimeters. So the length will be extension plus the unstretched length. And so you will have 3 centimeter plus 2 centimeter, and that will be 5 centimeter. So from the 5 centimeter, I will go to because the length will be 5. I will go to the graph and I can see that the reading is 15 Newton. So 15 Newton, D is the right choice. Let's check. Question number 8, D looks the right answer to us. Question number 8, D is the right answer. Let me show you my work also. The L naught is 2 centimeter. When the load is 0, the length of the spring is 2 centimeter. The extension is 3 centimeter. So the L will be L naught plus the extension. So 2 plus 3 equals to 5 centimeter. So on the y-axis, I will check where is the 5 centimeter length. From there, I will go to the graph. And from that graph, below that point, I will be able to check what is the load. So there will be a load of 15 Newton. So we are done with this question. D is the right answer. A 2 kg mass is moving at constant speed. The kinetic energy of the mass is 400 joules. What's the speed of the mass? You know the formula for the kinetic energy is 1/2 mv square. So I know the kinetic energy, I know the mass, and very easily I can find the speed of the mass. So let me show you how I have done this. So the mass is 2 kg, the kinetic energy is 400 joules, the velocity or the speed is question. We know the formula for the kinetic energy, that is 1/2 mv square. So 1/2 into 2 into v square equals to 400. The 400 joules kinetic energy is already given. So I will make the v square alone. 2 and 2 will be cancelled. So you will have v square equals to 400. So we will take square root on both the sides. So v will be 20 meter per second. 20 meter per second. So question number 9, B is the right choice. Yes, sir. That's right. Question number 9, B is the right choice. A crane moves its loads diagonally as shown. By what distance is the weight of the load multiplied in order to calculate the increase in the gravitational potential energy of the load? We always use the length and the height, vertical height for the gravitational potential energy. The vertical height gained by the load. So the vertical height gained by the load here is B. The vertical height gained by that load is B. The object moved from this point to this point, and the vertical height gained by the object is B. Question number 10. The efficiency of an electrical generator is 65%. Which useful output can be expected if the energy input to the generator is 12 kilojoules? So the input energy, I know that's 12 kilojoules. Kilo means 1,000. And so 12,000 joule energy is acting. That's the input energy. The generator is 65%. So the output energy will be 65 divided by 100 into 12,000 joules. Efficiency is 65%. Input energy is 12 kilojoules, which means 12,000 joules. Useful output energy is question. So the formula for the efficiency is useful output energy divided by input energy multiply 100. The efficiency is 65%. So I will write here 65 divided equals to x by 1200 multiply 100. So you see this 0, 0 and 0, 0 will be cancelled. So you have 120 multiplied 65 equals to x. So the x will be 65 into 127,800. So if I will divide it with the 1000, I will get the kilojoules. So 7,800 joules is the energy. And in the kilojoules, it will be, you divide it with the 1000, it will be 7.8 kilojoule. Let's check the answer. So I think question number 11, B is the right choice, 7.8 kilojoules. B is the right answer. Four different liquids are poured into identical measuring cylinders. The diagram shows the depth of the liquids and their densities. Which liquid causes the largest pressure on the base of the measuring cylinder? Here you can see in the diagram, in each option, the density of the liquid is given and the vertical depth of that liquid is also given. So I can find out the pressure produced by each means that each liquid or each cylinder. So let me show you my. So the pressure in the option A will be rho GH. Rho means the density. The G is 10 meter per second square, and H is the height. So you will height of the liquid or depth of the liquid above the bottom. So you will have 2 into 10 into 10, that will be 200. And for B part, it will be 1.6 into 10 into 20, so that will be 320. And 1.2 into 10 into 30, that will be 360. And 0.7 into 10 into 40, and that will be 280. So where is the largest pressure? The largest pressure is this one, this 360. 360 is the largest pressure. So C is the right choice. So this one has the right choice. This one is the right choice. Which of the following correctly compares the forces between the molecules in the steam, water, and the ice? So you see the weakest forces will be in the steam, and the strongest forces will be in the solenoid, and that is ice. So question number 13, the weakest will be steam, then water, then ice. So question number 13, C is the choice. Let's check. C is the right choice. On a hot day, a drink in a bottle can be kept cool by standing it in a bowl of water and placing a wet cloth over it. Why is the drink kept cool? You see, from the cloth, the water will evaporate. And when the water will evaporate, the molecules with the greater kinetic energy, they will leave. And the bottle will become cold. So why is the drink kept cool? Hot air cannot escape from the bottle. No, the cloth conducts heat from the bottle into the water, and the drink cannot evaporate from the bottle, or water evaporates from the cloth, cools the drink. So I think D is the best option. Question number 14, D is the right choice. Which instrument is more suitable for measuring a rapidly changing temperature? For this purpose, we always use thermocouple. So thermocouple is an instrument which will be able to measure very rapidly changing temperature. It can measure very high temperatures, it can measure very low temperature, plus it can measure the temperature which is changing very fastly. So question number 15, D is the choice. The graph shows the cooling curve of a hot substance. So here we have the room temperature is here. So when this graph, the cooling graph becomes flat, it means that some state is changing. In which part of the curve is the latent heat released? So the latent heat will release when the material is changing. And so the Q, from Q to R, we will have the latent heat. Q to R. 16, B is the choice. Yeah, our answer is right. The diagram shows the design of an alarm. The mercury pellet moves and completes the circuit. So here you have a mercury pellet. So when the temperature will rise, this gas will expand. It will push this drop towards this opening. So when the drop will come in this opening, the path of the current will be completed and the bell will, or the buzzer will ring. The mercury pellet moves and completes the circuit. Why does this happen? The mercury pellet moves and completes the circuit. Why does this happen? The gas will expand and the temperature will rise. D choice. Question number 17, I think D is the right choice. Okay. You see, when the temperature will rise, so the gas here will expand. So this will push this mercury pellet into this gap. When the mercury pellet will be in this gap, the path of the current will be completed and the buzzer will ring. So why does this happen? Because the temperature rises and the gas expands. D choice, question number 17. D choice, let's check. D is the right answer, sir. Water at the top of a hot water tank is heated and the water becomes hot. No water enters or leaves the tank. Water at the bottom of the tank stays cold for some time. Why is this? So here we have some reasons. He says the cold water at the top of the tank falls to the bottom. Hot water at the bottom of the tank rises to the top. Water is a poor conductor of heat, and the insulation is a poor conductor of heat. You see, when you have a heater here, so here the convection currents will happen. The convection currents will produced here. So they will heat the water above this heater. Water below this heater will remain cold. And the reason is by the convection, the heat only travels upward. The heat only travels upward. So here the heat can reach if the water is a good conductor. If the water is a good conductor. You know, the heat is not reaching below the heater. The reason is the water is a poor conductor of heat. So I think C is the right choice. I think C is the right choice. Question number 18. C is the right choice. Let's check. Yeah. The diagram shows the refraction of water waves as they cross a boundary in a ripple tank. So here you can see that the water waves are going in this direction. Here we have the boundary, and you can see that the wave fronts have come closer, a little closer to each other as compared to the here. So here the water is deep, here the water is shallow, here the speed of the water will be higher, here the speed will be slower, and the wavelength here is larger, the wavelength here is smaller. The frequency here and the frequency here remains constant, same. What causes this refraction? A change in the frequency due to a change in the depth. The frequency do not change. A change in frequency due to a change in wavelength. I told you that the frequency do not change. A change in speed due to a change in depth. Yes, that's the right answer. A change in speed due to a change in frequency. No, the frequency do not change. So I think C is the best option. Change in the speed due to a change in depth. Question number 19. C is the right choice. The diagram shows a ray of light reflected from a plane mirror. What's the angle of reflection? So here you see that we have a mirror here, and this is the incident ray, and this is the reflected ray. This is your normal. The angle of incidence here will be the angle between the incident ray and the normal. So that will be this angle. So angle of incidence and angle of reflection, you know, they are equal to each other. So let me show you my. So this total angle is 90. So if this angle is 30, the angle of incidence will be 90 minus 30, and that will be 60. So if the angle of incidence is 60, the angle of reflection will be equals to the angle of incidence. So the angle of reflection will be also 60. So the angle of reflection will be also 60. So the angle of reflection will be 60. So I think B is the right choice. Question number 20, B is the right choice. Yes. Which diagram correctly shows the dispersion of white light by a glass prism? You see, when the white light will enter into the glass prism, the light will be splitted, and white light will be split into its colors. And when they will emerge from the other face, the order of the colors will be Roy G. Biv. Roy G. Biv. Red, orange, it will be red. It will be Roy G. Biv. You see, it will be something like Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. So this is wrong. Why? Because here the light has not splitted. This is also wrong because the light was supposed to split when it enters the glass prism. This is right. This order is also right. So I think C is the right choice. 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 Question number 21. C is the right choice. Which does not normally use infrared radiation. Electric grill has infrared radiation. Intruder alarm, it uses infrared radiation. Television remote controller, it uses infrared radiation. Sunbed, yeah, sunbed use, the sunbed uses UV light. So which does not normally use infrared? Sunbed. D is the right choice. Question number 22, D is the right choice. A flash of lightning and the corresponding thunder clap are detected 6 seconds apart. It is calculated that the lightning struck about 1800 meters away. On which assumption is the calculation based? You see, they heard the thunder after 6 seconds and they think that the distance between the thunder and the observer is 1800 meters. So we can find the speed of the sound. Let me show you. So the time is 6 seconds. The distance is approximately 1800 meters. So the speed of the sound will be distance divided by time, and that will be 1800 meters divided by 6 seconds. So the speed of the sound is 300 meters per second. And the speed of the light, you have to remember this number is 3 expo 8 meter per second. So the speed of the sound is just 300 meter per second, where the speed of the light is 3 expo 8 meter per second. So the light reaches us almost instantaneously, but the sound travels at a speed of 300 meter per second. Yeah, that is the answer. The rest of the options are light travels 300 meters per second faster than the sound. That's wrong. Sound reaches us almost instantaneously, but light travels at 300 meters per second. That's wrong. The speed of the light is 3 expo 8 meters per second. The sound of the thunder was emitted 6 seconds after the flash. That's wrong. So question number 23, A is the choice. Yeah, A is the right choice. The diagram shows a model railway signal. What does the end P do when the switch is closed? You see, when this switch will be closed here, when this switch will be closed, you see the current will start flowing through this coil. So this coil will become electromagnet. And that electromagnet will definitely attract this nail. So this will move downward. When this will move downward, the P will move upward. So what does the NP do when the switch is closed? It goes down and stays down. No, it goes up and stays up. Yeah. It goes because this is alternating current here. The north and the south will be also alternating. they will be changing. The polarity of this electromagnet will be continuously changing. But because this is nail, whether here you have the North Pole or you have the South Pole, the nail will be always attracted. So it will always be moved downward and the P will stay up. It goes down and then returns to its original position. That's wrong. It goes up and then returns to its original position. No. So I think B is the right choice. Question number 24, B looks the best option to me. Yes, sir. Question number 24, B is the right option. Which part of our videotape recorder's system does not rely on magnetic material for its preparation? A drive motor, it uses the magnets. The power lead, it do not use the magnets. The transformer uses magnetic material. Its core is made of soft iron, which is a magnetic material. The videotape is also made of the magnetic material. So the only thing which is not made of the magnetic material is the power lead. Its cover is of plastic and its inner portion is made of the copper. So I think B. Let me check first. Question number 25, B is the right one. A positively charged insulated metal sphere is brought close to but not touching a similar uncharged metal sphere. So here you have a positively charged sphere and here you have uncharged sphere. So which diagram shows the charge distribution on the spheres? So when you bring them close, so due to the presence of this is called electrostatic induction. Here the charged particles will be disturbed. The free electrons will accumulate here. So this side will become negative and this side will become positive. So I think D is the best option. Question number 26, D is the right option. Yeah. Under which conditions does Ohm's law apply? Ohm's law says that the voltage used or consumed by a resistor is directly proportional to the current flowing through it, provided that the other physical conditions do not change, and especially the temperature do not change and the resistance do not change. So it says the current must be constant, no, the power must be constant, no, the temperature must be constant, yes. The temperature must be constant. And the voltage must be constant. C is the right choice. Question number 27, C is the right choice. A battery is used to light a 24-watt electric lamp. The battery provides a charge of 120 coulomb in 60 seconds. What is the potential difference across the bulb? Okay, so I know the amount of the charge. I know the time, that's 60 seconds. So I can find out the current. So I will be equal to the charge divided by time. So you will have 120 coulomb divided by 60 seconds. So you will have, I think, 2 ampere. So the current will be 2 ampere. The power is given, the P is equals to IV. The formula for the electric power is P equals to IV. P equals to IV. So I know the power, that's 24 watts. I know the I, that is 2 ampere, and we can calculate the V. So let me show you my calculation. I've done this on a paper. So here we go. P is equal to 24 watt. The charge flowing is 120 coulomb. The time in which the charge flows is 60 seconds. So the I will be Q divided by T. So it will be 120 divided by 60. So it will be 2 ampere. So once you know the current flowing, then I can apply the formula of the power. Power is equal to IV. The power is 24. The I is 2 ampere. The voltage is question. So V will be equals to 24 divided by 2, and that will be 12 volt. 12 volt. So question number 28, 12 volt. Question number 28, 12 volt. So question number 28, 12 volt, B is the right option, sir. Yeah. A student sets up the circuit shown. The currents measured with the ammeters are shown which equation is correct. You see, the current coming from the battery is I1. Here the current will be splitted. I2 current is passing from the first branch. I3 current is passing through the second branch. And I4 current is passing through the third branch. So the I1, which is coming from the battery, will be equals to the sum of the currents which are in the branch number 2, branch number 3, and branch number 4. So I1 will be equals to I2 plus I3 plus I4. So the current I1 will be equals to I2 plus I3 plus I4. I think A is the right option. Okay. A is the right option. Question number 29. A is the right option, sir. Question number 29, A is the right option. The following circuit is set up. What is the reading on the ammeter? So you can see, I want to know what's the reading here. So first of all, I will find out what's the combined resistance of these two. They are parallel to each other, so their resistance will be, plus they are identical to each other, they are parallel to each other. So I can find their resultant force, resistance. And once I know the resistance of these two, then I can add this resistance and I will know the resistance of the whole circuit. Then once I know the resistance of the whole circuit, I will, the voltage of the battery is given. From there, I will calculate what is the current. So when that current which will come out of the battery will reach this junction, it will find two paths. You can see in both the paths, the resistance is same. So the current will be divided into two equal parts. So very easily I can tell. Let me show you. So first of all, R1 and R2, I will find out what is their equivalent resistance. So 1 by R4 will be equal to 1 by R1 plus 1 by R2. So 1 by R4 will be equal to 1 by 6 plus 1 by 6. So 1 by R4 will be 2 by 6 and it will be 1 by 3 after cutting. So the R4 will be equals to 3 ohm. So the combined resistance of these two will be 3 ohm. Now this 3 ohm and this 3 ohm, they are connected in series with each other. So their resultant will be 6 ampere. So R4 plus R3, that will be 3 plus 3 and that will be 6 ohm. So once you know the resistance, the total resistance of the whole circuit, and you know the voltage of the battery, so I can calculate how much current will come out of the battery. So the current from the battery will be equals to the EMF divided by the total resistance. So that will be of the circuit, I mean, the 6 divided by 6, and that will be 1 ampere. So from the battery, 1 ampere will come out. So from 1 ampere current when reaches this point, both the branches have the equal resistance, so the current will be equally divided. So the current flowing through the branch number 1 will be 1 by 2 of the current coming from the battery. And so that current is 1 ampere. So 1 divided by 2, and that will be 0.5 ampere. So this is how you do this question number 30. And the question was, what is the reading on the ammeter? And that will be 0.5 ampere. So I think question number, I think that the question number 30, B is the right choice. This has become larger, able to, okay. So B is the answer. So question number 30, B is the right option. He says that the energy is represented by the letter E, current by I, power by P, charge by Q, and the potential difference by V, and the time by T. Which pair of the equations is correct? You know the energy, the electric energy, the formula is VIT, and the power is VI. This is the famous formula. The electric energy formula is VIT, and the power is VI. So I think it's no doubt a very simple question. I think C is the right choice. Question number 31, let's check the answer. Question number 31, C is the right answer, sir. The case of an electric fan is earth. The plug to the fan contains a 5 ampere fuse. There is a current of 4 ampere when the fan works normally. The cable to the fan becomes so worn that the live wire makes electrical contact with the metal case. So what happens? You see, because this is connected with a fuse, so when the current will exceed its limit, or because the body has the insulation on the wire has broken, so now the body of that machine is also in contact with the live current. So that live current will go. I mean, there they have connected an earth wire. So through the earth wire, the current will start going into the ground. So the fuse will melt because the current will be going to the electric fan, plus it will be also going to the ground. So the amount of current flowing will become more than 4 amperes. So the fuse will blow. When the fuse will blow, because the fuse is connected in the live wire. So when the fuse goes, it blows. So you see, your machine will be cut off from the main supply. So your machine will be isolated from the live current. So the cable to the fan becomes so worn that the live wire makes electrical contact with the metal case. What happens? The current flows to the earth and the fuse is not affected. That's wrong. The fuse will melt when the current will exceed the certain limit. The fuse melts and switches off the circuit. That is possible. The metal case becomes live. The metal case becomes live and dangerous. The metal case becomes very hot. So I think the fuse melts and switches off the circuit. That's the best option I can understand. So question number B, 32B is the right option. Okay, question number 32B is the right answer, sir. The diagram shows a beam of electrons entering a magnetic field. The direction of the field is into the page. In which direction are the electrons deflected? So here we will apply the left hand rule. According to the left hand rule, this is my left hand. Stretch these fingers such that they are perpendicular to each other. This thumb is showing the direction of the force. This index finger is showing the direction of the magnetic field. And this middle finger is showing the direction of the current. But this law is about the conventional current, not about the electrons. So let's apply on the electrons. Let's see what happens. So the magnetic field is shows magnetic field is into the page. So my magnetic field finger is pointing into the screen. The charged particles are going in this direction. They are going towards the right, and my thumb is pointing upward. So according to this law, the electron beam should be deflected upward, but remember, the electron beam is negative. So that's why the electron beam is negative. So the electron beam will deflect in opposite direction, whatever is predicted by your left-hand rule. So if my left-hand rule says that the electron beam will be deflected upward, it will be deflected downward, because the left-hand rule from where I'm telling you the direction in which the body will move, that is based on positive charges. It's not based on negative charges. So I think in which direction are the electrons deflected into the page, out of the page, and towards the bottom of the page. You see, it will be deflected towards the bottom of the page. (33C) is the choice. Yeah, 33C is the right choice. Which single coil motor will have the largest turning effect? So the turning effect depends upon the current in the coil. It should be largest. Number of turns in the coil, it should also be large. And iron core should be present. So the iron core, yes, and the number of turns on the coil should be more than the number of, sorry, you see the iron core should be present in the motor, and number of turns in the coil should be largest, and the current should also be larger. So I think D is the right choice. Question number 34, D is the right choice. Question number 34, D is the right option. A small coil is connected to a sensitive thermometer. A small coil is connected to a sensitive ammeter. The ammeter needle can move to the either side of the zero position. As the magnet falls towards the coil, the ammeter needle moves quickly to the right of the zero position. The magnet moves through the coil. How does the ammeter needle moves as the magnet falls away from the coil? So it does not move. It gives a steady reading to the right. So in which direction first that has moved? It has moved towards the right. So this time, I think, when the north was entering the coil, the pointer moved to the right. So when the south will be leaving from this end, so I think the deflection should be in the opposite direction. So let's check question number 35. Question number 35C is the right choice. It moves quickly to the left of the zero position and then returns to the zero. Yes, it will be deflected in the opposite direction. The diagram shows transformers and cables used to transmit electric energy over long distances. How does the transformer affects the voltage and the current from the power station? You see the transformer which is used on the near the power station. That is a step-up transformer, and it increases the voltage. And when the voltage is increased, the current will decrease, and that helps to reduce the power loss in the transmission lines when you reduce the amount of current. So the voltage that will increase, but the current will decrease. So C is the choice. Question number 36. I think C is the right option. In the circuit shown, all lamps are identical and all cells are identical. The resistance of the coil in the reed switch is negligible. One cell lights one lamp to normal brightness. What is the brightness of the lamps when the switch Y is closed? So he says that each one lamp will be at normal brightness when it is connected with the one cell. So because this is reed relay, when you will close the switch Y, so in this circuit, the current will start flowing due to the coil. Here electromagnet will be formed, and that will cause these contacts to touch each other. So this will make, in this upper circuit, the path of the current will be completed. So the current will start flowing in this circuit also. But this circuit and this circuit, they are not connected to each other electrically. So in this circuit, this cell is supplying electric energy to only one lamp. So the P will be in the normal brightness. Here, this cell is providing electric energy to these two cells, which are connected in series with each other. So they both will be dim, because this one cell was good for one cell. This one cell was good for one lamp only. So here you have connected two lamps, so they will be dim. So the P will be at the normal brightness, and the R and Q, they will be dim. So I think B is the choice. Question number 37, I think B is the right choice, I think. So let's check. Question number 37. B is the right option. An experimenter sets up the following apparatus in air to discover whether a radioactive source is emitting alpha particles. So here you can see we have a radioactive source. Here the distance between the detector and the radioactive source is 30 centimeter. So this is going to the counting device. So this is radiation detector. So here he can insert the paper sheet or aluminum sheet or whatever he wants to put between the radioactive source and the detector. The experimenter moves the paper between the source and the detector. There is no difference in the count rate. Why is this so? You see, this radioactive source is probably giving out, emitting alpha particles. So the alpha particles, they cannot travel 30 centimeters in the air. So basically the alpha particles are not reaching the detector, and this detector is only noting down the background radiation. So when you inserted the paper between the detector and the radioactive source, the alpha particles were not coming this near this detector. So this was taking the reading on the background. So when you insert the paper sheet here, it will still be noting down what's the reading of the background radiation. So that's why the reading on the counting device will not change. So why is this? So paper does not absorb alpha particles. That's wrong. The count rate due to the background radiation is too high. That's wrong. The radioactive source is too far from the detector. That is true. The source emits beta particles and not alpha particles. In the question, they said that is emitting, an experimenter sets up the following apparatus in air to discover whether radioactive source is emitting alpha particles. Either it is C, or the source emits beta particles and alpha particles, because here he wants to discover whether a radioactive source is emitting alpha particles. So if the detector is not noting down the background radiation, then the other possibility can be that the source is emitting beta particles and the alpha particles. But if it will be emitting alpha particles, the paper will stop them. C or D? I think D is C, because we doubt that it is only emitting alpha particles, and the alpha particles cannot reach the detector because they cannot penetrate 30 centimeters in the air. So either the counting device, the detector, is noting down the background radiation. Okay, so let's check first of the answer. So let's see. Question number, which question was this? Question number 38. Question number 38, C is the right option. So our first option was right. The half-life of a radioisotope is 2400 years. The activity of a sample is 720 counts per second. How long will it take for the activity to fall to 90 counts per second? So let me show you how I have done this. So the half-life is 2400 years. Then the count rate and the counts per second is 720. And at the end, the counts will be 90. So let's see, when one half-life will pass, this 720 will become half, it will become 360. When another half-life will pass, this 360 will half and it will become 180. When another half-life will pass, this 180 will half and it will become. So they were talking about this number. So 1, 2, 3, 3 half-lives have passed. One half-life is 2400 years. So the 3 half-lives will be 3 multiplied 2400. So it will be 7200 years. 7200 years. $7,200 years. I think C is the choice. Yeah, C is the choice. The last one is, he says that the neutral atom of all isotopes of the same element contain the same number of electrons and protons. Electrons and neutrons. Neutrons only, neutrons and protons. So the isotopes of the same element will have the same number of protons and same number of electrons. So I think A is the choice. Question number 40, A is the question number 40, A is the right. So my dear students, we have reached the end of this paper. So today, so my dear students, today we have done October-November 2007 paper. Paper 1 we have done, and this paper was an MCQ paper. And hopefully this video has helped you. Hopefully this video will help you to understand the concepts of the physics and prepare your MCQ paper, and also prepare your physics for the upcoming Cambridge exam. If you find this video helpful to you, don't forget to subscribe to my YouTube channel and to like my video. If you think that this video is helpful, kindly share this video with your friends who are in O level, and post the link of this video in your Facebook accounts and on your Instagram, because this will help me to promote my YouTube channel, and that will be a very good, it will be a great encouragement for me, and I will be able to continue this work. So it was a great pleasure to teach you all through this YouTube channel. So thank you very much, and have a good day, and God bless.